Okay, so we're going to start with this unit. It's called exponential and logarithmic functions. But before we get to logarithmic functions, which will be in the next video, it might not be my video, might be a video that made by another teacher, most likely Mr. Gonzalez. But that's for another day. But for now, it will be exponential and exponential functions. All right, so what is an exponential function? Exponential functions are functions that are usually written like this. Y equals a times b to the power of x. Now, why do we call it exponential? Because x is an exponent, obviously. All right, so we have two types of exponential functions. We have what we call exponential growth. And I hope you guys can read my beautiful handwriting. You guys haven't forgotten about my beautiful handwriting, have you? All right, so exponential growth. Exponential growth, if you graph it, it looks something like this. It's a curve that shoots up really fast. For example, in real life, bacterial growth. If you put bacteria, a certain number of bacteria in an area where there's good environment for their growth with proper nutrition, their population explodes, as we call it, exponentially. So the graph is like that. Now, how do we know if by looking at an equation, if we are dealing with an exponential growth? We look at the the base of your exponent, b. If it's greater than 1, then we have an exponential growth. And then we have exponential decay. And if you graph them, they generally look something like this. And that's when the base is between 1 and 0. Now, we have shown this in our notes. If you guys remember our notes, for every unit we had one of these notes. You see exponential growth, that's the standard or the parent function, and this is decay. Well, I wouldn't say parent function, but one of the basic functions. So you see growth goes up like this. That's an example. You see the base is greater than 1. That's why it's growth. Look at the red one. It's going down. That's exponential decay. And look at the base of its function. It's 1/2. 1/2 is between 0 and 1. So that's how we get decay. All right, so let's do some examples from the review A in your packet, which will be uploaded into the Google Classroom. So look at this one. It says graph each function and label important features. So let's do the first one. So let's do that. So we have f of x equals to 2 to the power of x. Now, if you notice, the base is greater than 1, therefore we know it's exponential growth. So what do we do with these problems is you set up a table, XY table, and just pick a couple of numbers. And for the purposes of this lesson, I would just recommend 3 numbers: -1, 0, and +1. So let's start with the easy one. If I put a 1 over here, what's 2 to the power of 1? 2 to the power of 1 is 2. So the y value is 2. If I put a 0 here in place of x, what's 2 to the power of 0? If you guys remember from your last unit, which we just finished, and let me show you this one. I think everybody has this. Do you guys remember? Anything to the power of 0 is 1. So if we remember that from the last unit, so 2 to the power of 0 is 1. Now, what if x is a -1? So what do we get? We get, well, f of x is our y, so we get y is 2 to the power of -1. Now, if you guys again remember, if you have a quantity raised to a negative power, what do we do to get rid of the negative power? We flip it. We take its reciprocal. So it will be 1 over 2 to the power of positive 1, or just 1 over 2, 1/2. So this will be 1/2. Okay, so how do we graph this now? So very simply, you do this. This is your x-axis, this is your y-axis, horizontal, vertical axis. I hope everybody remembers these. So you go 1, and the y value is 2. You go 0 and 1, and you go -1 and 1/2. Now I'm estimating halfway between here. It's about there. Okay, and we know it's exponential growth. So there is the curve going up. Okay, now mind you, for exponential growth and decay, please don't graph like this. The end of it doesn't go up. This end of the graph keeps getting closer and closer to the x-axis. It will never touch it, but it will come closer and closer. So it doesn't go up. So don't graph like that, like this. All right, so what are the important features that the problem is asking you about? The important features is that we write its growth, or exponential growth. We write the y-intercept, which is whenever the x is 0, and that's obvious, 0 and 1. We also write the equation of what we call the asymptote. Asymptote. Now, what is an asymptote? Asymptote is a line where the graph comes very close to, but it doesn't cross or touch that line. So in this case, you see, our graph here comes very close to the x-axis, but it will never touch or cross it. So in this case, in the case of this problem, the asymptote is our x-axis. But we always write the equation of the asymptote. Asymptote is a line. So how do we write the equation? This is a horizontal line, correct? If you guys remember from Unit 1, horizontal lines are always written as y equals to some kind of a number, right? So this is a horizontal line. So we know the equation of it would be y equals. Now where does it cross the y-axis? This x-axis crossed the y-axis at 0. So the equation of this asymptote in the case of this problem is y equals to 0. So what are our important features? You have a table of values, you have the graph, you write whether it's growth or decay, you indicate where the y-intercept is, and you give me the equation of the asymptote. Again, asymptote is a line, not a point. So that's why the equation has to be written as y equals to something. So for the purposes of exponential growth and decay, the asymptote is always a horizontal line. So it's always y equals to a number. Now, a lot of times it's the x-axis, but sometimes it might not be the x-axis. Let's do another problem. Let's do this problem. Y equals, or f of x equals 1/2 of x. Okay, so this is number 2. So f of x equals 1/2 to the power of x. Now, we know that the base of our exponent is what? It's 1/2. So if it's 1/2, that's between 0 and 1, right? So we know it's exponential decay. So we know the graph is going to go down like that. One thing that I remember, we wrote the general equation as y equals ab to the power of x, right? So what is our a in this? The first equation we did. The a is 1. So 1, we can write it as 1 times 2 to the power of x. Okay, we just don't show the 1. The b is the 2. So in this case, the a again is 1. So 1 times 1/2 to the power of x. Okay. All right. So again, make a little table. How about 1, 0, -1, or you can put -1 first. So what's 1/2 to the power of 1? It's just 1/2. What's 1/2 to the power of 0? Anything to the power of 0 is 1. What is 1/2 to the power of -1? Remember, y equals to 1/2 to the power of -1. Again, if you have, from the last unit, if you have a fraction with a negative exponent, how do you get rid of that negative exponent? You flip the fraction. So let's flip the fraction. So what do we have? We have 2 to the power of 1. This becomes positive once you flip the fraction. So that's 2. So there you go. So now we graph it. And we have 1 and 1/2. I'm going to make the graphs a little bigger. We have 0 and 1. We have -1 and 2. So now you know the graph is going to go like that. So that's exponential decay. So what are the important features? We know it's decay. We have a table of values. We have the graph. What is the y-intercept? It just happens to be 0 and 1 again. And what's the equation of the asymptote? All right, so it's coming very close to the x-axis again, right? This is our x-axis. So it's a horizontal line. So we write y equals, where is it crossing the y-axis? 0. So there is the equation of the asymptote. I'm going to stop right here. We're going to continue in the next video.